Good evening friends, you are most welcome to Think Eyes channel. Today we are going to discuss Practicing Anthropology by MAAN IGNOU, and our topic is Physical or Physiological Anthropology, in which we are going to discuss impact of air pollution on cardiorespiratory functions. Let us begin the topic. Over the last decade, accumulating epidemiological and clinical evidence has led to a heightened concern about the potential deleterious effects of ambient air pollution on pulmonary and cardiovascular system, depending on the physical and chemical properties of contaminants, time and frequency of exposure. The concerned environmental air pollutants include carbon monoxide, oxides of nitrogen, sulfur dioxide, ozone, lead and particulate matter, thoracic particles PM10, fine particles PM2.5, coarse particles PM10 to PM2.5. These pollutants are associated with increased hospitalization and mortality due to cardiovascular disease, especially in persons with congestive heart failure, frequent arrhythmias, or both. Brook et al. 2004. The cardiac effects are a consequence of inflammation in the lung, leading to the release of cytokines with secondary effect on blood constituents interfering with coagulability and stability of atheromatous plaques. Seaton et al. 1995. The lung inflammation is a consequence not of the mass but of the number of particles, particularly those in the ultrafine less than 100 nanometer size range. It has the potential to explain both short-term morbidity and also longer-term atherogenesis. Other hypotheses suggest that inhalation of air pollutants might trigger reflex changes in the control of heart. Aries 2006. Increased parasympathetic activity normally leads to coronary vasodilation. In the presence of coronary artery disease, parasympathetic stimulation may lead to net coronary constriction. Pope et al. 2004. Accelerated heart rate, diminished heart rate variability (HRV), and increased incidence of arrhythmias on exposure to air pollution suggest the primary effects on myocardial excitability or autonomic regulation of the heart or both. Lung function, as measured by spirometry, is an excellent operative marker of the effect of air pollution. It is objective and quantitative, an early predictor of cardiorespiratory morbidity and mortality, able to describe trajectories to the occurrence of chronic obstructive pulmonary disease (COPD), and coherent with experimental data on deposition and accumulation of pollutants in airways and lungs and the resulting systematic inflammation and oxidative stress. Sun 2009. Understanding and quantifying the contributions of environmental exposures to lung disease is difficult because individuals respond differently to the same factors. The variation in response arises from different susceptibilities, including genetic predisposition, developmental stages of life, presence of coexisting diseases, other exposures, and lifestyle differences such as varying nutritional status and physical activity levels. Long-term exposure to smoke or dust damages the lung, airways, and air sacs and may eventually cause chronic obstructive pulmonary disease (COPD) indicated by FEV less than 0.80. COPD is characterized by chronic inflammation throughout the airways, parenchyma, and pulmonary vasculature. People with COPD usually have a combination of two conditions, chronic bronchitis and emphysema. In chronic bronchitis, the airways become inflamed and their walls thicken so that the air passage narrows down, which you can see in figure 2.1. The damaged airways also produce a lot of thick, sticky mucus, which causes frequent coughing and emphysema. Destruction of lung parenchyma leads to the loss of elastic recoil and alveolar septa, which increases the tendency for airways collapse. The combination of these two conditions obstructs airflows through the lungs and the individual becomes increasingly breathless and fatigued. The damage caused to the lungs is irreversible, and the condition is progressive. That is, the damage gradually accumulates and the symptoms worsen. Indoor air pollution from biomass fuel burned for cooking and heating in poorly vented dwellings has also been implicated as a risk factor for the development of COPD disease. The long-term adverse effect of air pollution on lungs has been evident among children during their development. Cumulative pollution related deficits in the average growth in lung functions results in the strong association between exposure to the air pollution and a clinically low FEV at the age of 18 years. FVC is largely a function of the number and size of alveoli, with differences in volume primarily attributed to differences in the number of alveoli since their size is relatively constant. However, since the postnatal increase in the number of alveoli is complete by the age of 10 years, pollution related deficits in the growth of FVC and FEV during adolescence may in part reflect a reduction in the growth of alveoli. Another plausible mechanism of the effect of air pollution on lung development is airway inflammation, such as occurs in bronchiolitis. Such changes have been observed in the airways of smokers and of subjects who lived in polluted environments. Gordon et al. 2004. Here you can see the picture. First, there is a normal airways. Second, that is the case of chronic bronchitis. Here mucus is increased. There is a pulp-like structure, cross-sectional structure, inflammation and structural changes. Here you can see a human body in which left and right parts. One part shows lungs, and inside lungs there is a air sacs and airways. There are air sacs and airways, and there is a windpipe. On the right side you can see air sacs, normal air sacs, and in which you can see it is like a grape structure. And second case is emphysema, in which you can see destruction of the air sac walls and enlargement of air spaces. This picture shows the lungs are filled with a network of airways and air sacs. In COPD, damage to the lungs results in narrowing of the airways and destruction of the walls of the air sacs. There is negative dose dependent association between various outdoor exposures and lower levels of the forced expiratory volume in 1 second FEV, forced vital capacity and maximal mid expiratory flow rate. There is a negative dose dependent association between various outdoor exposures and lower levels of the forced expiratory volume in 1 second FEV, forced vital capacity and maximal mid expiratory flow rate. The short-term negative impact of exposure to air pollutants on respiratory volume and flow is limited to individuals with already impaired respiratory function. Individuals with chronic obstructive pulmonary disease COPD, including asthma, ischemic heart disease, IHD, congestive heart failure, heart rhythm disorders, and diabetes are frail population susceptible to the acute effects of the air pollution. Decrements in lung function indicates FVC and or FEV associated with increasing concentrations. Next heading is impact of smoking on cardiorespiratory functions. Of all inhalation exposures, cigarette smoking is the major factor which contributes to the risk of pulmonary disease in most countries. When the tobacco leaf is burned, the smoker is exposed to over 4,000 chemicals, a large number of them being carcinogenic, affecting almost all organs. Many other organic and inorganic chemicals in the gaseous, volatile, and particulate phases of cigarette smoke appear to contribute to smoke's toxicity to the respiratory system, including hydrocarbons, aldehydes, ketones, organic acids, phenols, cyanides, acrolein, and nitrogen oxides. Cigarette smokers have a higher prevalence of lung functions abnormalities and respiratory symptoms, a greater annual rate of decline in FEV, and higher death rates for COPD than non smokers. The patient will have a reduced FEV and or FVC ratio. Cigarette smoke is toxic to the cilia that line the central breathing passages. Some components contribute to the development of chronic mucus hypersecretion in the central airways, whereas others play a greater role in the production of emphysematous injury to the peripheral air sacs. Smoking also indicates abnormalities in the inflammatory and immune system within the causing inflammatory cells to produce an enzyme called elastase, which in turn breaks down elastin, an important protein that lines the elastic walls of the air sacs. Farah et al. 1986, US Department of Health and Human Services, 1984. Moreover, oxidants present in the cigarette smoke can inactivate a separate protective enzyme called alpha antitrypsin, which inhibits the destructive action of elastase. Smoking during pregnancy may also pose a risk for the fetus by affecting lung growth and development in utero and possibly the priming of the immune system. Cigarette smoking is a major contributing cause to coronary heart disease (CHD), stroke, and other atherosclerotic diseases of the circulatory system. The relationship between cigarettes consumption and relative risk of coronary heart disease appears to be independent of other factors such as raised serum cholesterol, hypertension, obesity, and physical inactivity. Smokers are at twofold increased risk of CHD and than non-smokers. Smokers are at twofold increased risk of CHD than non-smokers. Nicotine, the major psychoactive component of smoke, increases heart rate and blood pressure via stimulation of autonomic nerves. It affects cholesterol metabolism by lowering the levels of protective high density lipoprotein HDL cholesterol and increasing bad cholesterol low density lipoprotein LDL. Nicotine damages the inner lining of blood vessels, thus enhancing the transfer of low density lipoprotein LDL cholesterol particles across the arterial wall and development of cholesterol laden plaque. Furthermore, smokers have elevated levels of thrombin, an enzyme that causes the blood to clot. The adherence of blood platelets to the lining of arterial blood vessels and the formation of blood clots, narrowing down artery. Willett et al. 1983, Pitillo et al. 1984, Penn et al. 1994. Carbon monoxide in cigarette smoke binds. Carbon monoxide in cigarette smoke binds to the hemoglobin in red blood cells (RBC), thereby reducing the oxygen carrying capacity of the blood. Impact of occupation on cardiorespiratory function. Occupational lifetime exposure to dust, fumes, endotoxin, organic dust, and sensitizing agents evaluated in the general population have found to be associated with airway hyperresponsiveness, chronic bronchitis, and airflow obstruction. The effect of occupational exposure on lung function is related with the duration of exposure. When the exposures are sufficiently intense or prolonged, occupational dust and chemicals, vapors, irritants, fumes can cause COPD independently of cigarette smoking and increase the risk of the disease in the presence of concurrent cigarette smoking. The airways from nares to alveoli come into contact with 14,000 liters of air in the workplace during a 40-hour work week. Physical activity can increase ventilation and thus exposure to contaminants up to 12 times the level at rest. As ventilation increases, breathing shifts from nasal to a combination of oral and nasal, allowing a greater volume of air to bypass the cleansing nasopharynx and further increasing the exposure of the lower airways to inhaled materials. Strong irritants such as ammonia produce an aversive response, whereas materials with little sensory effect, such as asbestos, can be inhaled for prolonged periods and result in serious injury. Beckett 2000. It has also been suggested that the occurrence of respiratory symptoms represent the earliest response and a risk factor for subsequent loss of pulmonary function. Cumulative exposure to dust and increasing working years in specific jobs have been associated with a steeper decline in FEV1. Jean et al. 2006. The spirometric parameters estimate among individuals exposed to ambient levels of particulate matter dust shows dose response relationships more pronounced for forced vital capacity FVC compared to forced expiratory volume in first second FEV1. Forced expiratory volume in first second FEV1 is the volume of air expressed in liters exhaled in the first second of the FVC forced vital capacity maneuver and it is decreased in obstructive lung disease while restrictive lung disease decreases FVC forced vital capacity. Forced mid respiratory flow rate FMEF or FEF 25 to 75% is the rate of flow of air between 25% and 75% of the FVC force vital capacity. It is a sensitive measurement and is determined from force expiratory spirogram. It is reduced in early obstruction involving the smaller airways, which are the primary site of deposition of inhaled pollutants. Jeffrey et al. 2007. Such relationship between occupational exposure and overshift changes in lung function has been documented in different occupational setups such as coal mine, textile factory, grain processing and animal feed industry, etc. Barometric pressure is elevated in deep underground mines and reduced at high altitude mines. Chronic intermittent hypoxia at altitude has been reported to induce physiological adaptation and symptoms of benign acute mountain sickness AMS in mine workers, while increased barometric pressure in deep mines increase air temperatures, increase convective heat exchange and reduce sweat evaporation rates. Ambient exposure to particulate matter, air pollution such as silica dust, asbestos, or welding fumes is a risk factor for cardiovascular disease. It has been proposed that inhalation of small particles induces an inflammatory reaction in the airways and subsequent induction of the systematic inflammation and coagulation disturbances. Seaton et al. 1999. Intermittent exposure to magnetic fields leads to reduction in heart rate variability and arrhythmia. Heart rate variability is a marker. Heart rate variability is a marker of Heart rate variability is a marker of autonomic cardiac control, and reduction in heart rate variability have been shown to predict sudden death, all-cause mortality, and heart disease is prospective epidemiological studies. Hakan Sonnet et al. 2003। इसको फिर से देख लेते हैं। Barometric pressure is elevated in deep underground mines and reduced at high altitude mines. Chronic intermittent hypoxia at altitude has been reported to induce physiological adaptations and symptoms of basic acute mountain sickness (AMS) in mine workers, while increased barometric pressure in deep mines increase air temperatures, increase convective heat exchange, and reduce sweat evaporation rates. Ambient exposure to particulate matter, air pollution such as silica dust, asbestos, or welding fumes is a risk factor for cardiovascular disease. It has been proposed that inhalation of small particles induces an inflammatory reaction in the airways and subsequent induction of the systemic inflammation and coagulation disturbances. Seaton et al. 1999. Intermittent exposure to magnetic field leads to reduction in heart rate variability and arrhythmia. Heart rate variability is a marker of autonomic cardiac control, and reductions in heart rate variability have been shown to predict sudden death, all-cause mortality, and heart disease is prospective epidemiologic studies. Hackenson et al. 2003. At the last, we will discuss summary. The increasing epidemic of health risk has paved way for health promotion policies which focus purely on behavioral change and towards ecological approaches that involve communities in nurturing environment and behavioral changes. It is because of this trend there is an increased popularity of interdisciplinary and participatory approaches to health related issues. Anthropologists facilitate in the understanding of the interaction of physical and social environmental conditions that can be strong participants in such an integrally interdisciplinary approach. In this unit, we will learn how various physiological dimensions are used in practicing anthropology. In this unit, we learn how various physiological dimensions are used in practicing anthropology. It is well understood that the heart provides the force to push blood throughout the vascular circuit. The epidemiological research over the years established elevated blood pressure as a major contributor of cardiovascular disease, and that increase both systolic and diastolic blood pressure are associated with strong continuous increases in the risk of stroke, coronary heart disease, congestive heart failure, peripheral vascular disease, and the renal disease across a very broad range of blood pressure levels. Heart rate measured by monitoring one's pulse differs significantly between individuals based on fitness, age, and genetics. Cardiovascular fitness is designated as the most significant component of health-related fitness and remains a significant predictor of hypertension. STEP test classifies individuals according to level of cardiovascular fitness. Epidemiological and clinical signals have led to a heightened concern about the potential harmful effects of ambient air pollution on pulmonary and cardiovascular system depending on the physical and chemical properties of contaminants, time and frequency of exposure. Cigarette smoking is the major factor which contributes to the risk of pulmonary disease in most countries, whereas occupational lifetime exposure to dust, fumes, endotoxin, organic dust, and sensitizing agents evaluated in the general population have found to be associated with chronic bronchitis and airflow obstruction. Thank you very much.